take a look. Good friend trying to look for margins of error. Makes me happy, sister. How the hell is it that this has a plus or minus 2% margin when the Gallup poll had a plus or minus 4?
3,500.
Ho-ho! Look at the sample size, yeah? The Gallup poll had a much smaller sample. Because it has a much smaller sample, you must accept more uncertainty. That's the definition. We're gonna attack that mathematically in about 5 minutes. I want to get in there mathematically. But that's the difference. So now if we make some tanks, let's make some tanks. There, I slapped up January 2014. They said it's 29% of likely U.S. voters, plus or minus 2%. That should go 27 to 31, yes? I'm assuming. I did the math correct. I did it right. Add 2. It looks like over there, a year ago, 36%. I think I put the wrong date on there. I said October 2013. It was a year ago to January 2013. But it was at 36%, which means if we apply the same margin, the problem was I couldn't find that poll. So I couldn't put the correct margin on, so I assumed it was also 2%. But even if it was 3%, right, or 4%, I still claim there's a difference in a year ago from today. Even if this bad boy had a 4% margin of error, correct? Because if it had a 4%, it would come out to here and here. Which means there'd still be a gap between the two intervals, which means I still think there's a difference. Now, if it was a 4% margin of error, what would the MMD be? Minimum measurable difference, remember that from the foreclosure rates? What would the MMD be if it was a 4% margin of error? 1 percentage point. But as it is right now, assuming it's 2% like the current poll, what's the MMD? 3% minimally different, right? That's worst case scenario. If this is pegged at the low end and this is pegged at the high end, it's a 3% difference, at least. Might be more. Using the fish being the... Are the fish helpful? Imagine the fish as the parameters. They're the parameters. They're swimming around in the tank. You just don't know where they are. So they can't touch each other, right? The one fish can't get to the other one. There's no way of it getting to the other one. Which means that they are different fish. I.e., the percentage difference in 2013 is different than 2014. Please, Emily!
What if they're like flush?
Good! Very good question. Who wants to answer that? Cass, I'll give you your question too. Did you hear what Emily just said? What if both of these had an increase? Ooh! They're both at 2% right now, right? What margin of error would they have to be to make them exactly flush with each other? Oh, that's a good mathematical question. If we did this, what would they have to have? Margin of error. Vote for 3.5?
No. Wait, no.
Well, we have to, if we want them both to change, if we want both of these to increase at the same, so they touch right here, they'd have to split the difference of 3, yes? So 1.5 and 1.5?
But it'd have to be over
plus
that.
Hold that thought, hold that thought, sister, hold that thought. Emily's asking, what happens if they are exactly touching each other?
Oh.
See, that's her question. What if they bump up? They're 0, essentially, right? There is no minimum, but they're. First of all, here's a quick and easy answer. It never happens. It never happens. We got close, but close is different than exactly the same. And the reason I say it never happens, as soon as you introduce the normal distribution, you've got a continuous random variable, which means there's an infinity of values between them, and the chance of them landing exactly on top essentially disappears. Fair enough? Now, what you're saying is, what happens if the percentages round to the same value? So suppose that the minimum difference is like 0.1%, which is so close it rounds to 0. What would I tell the statisticians to do? Go out and get more data. Now, why would I tell them to do that? Why would I tell them to go out and get more data? Yes, if there is truly a difference, if you get more data, your margins are going to do this, which means that minimum difference is going to be more exaggerated. If there's a difference, and it's not just flukes. It's funny, on that mathematical headlines from a literate world, one of the studies, the headlines is, researchers tout surprising new findings. The mathematical literate headline is, researchers promise to replicate new findings before touting them. That's the point. Go get more data, see if it holds up. Fair? Cassidy.
So going back to the MMP.
Yes, ma'am.
Could you re-explain why it's 1?
Oh, now it's not 1 right here. Here it's 3. Here it's 3. My point was, supposing this stretched with a 4% margin of error all the way out to here, there's only 1 percentage point between them. I'm sorry, I got ahead of I let the cart lead the horse there. I should have just stuck with the picture I have on the board. Yes? Good. Thank you for that question. Fit, please.
Just to specify
Yes.
that you're doing 95% confidence? Or
Yes.
that's just
This is a good question. Assume 95% confidence unless told otherwise. It's used so frequently in research. I'm not saying it's a good thing. I'm saying it's used. I'm saying it's used. Kind of like we always drive on the right side of the road. I'm not saying it's a good thing. I'm saying it's what we do. It's a habit that we fall into. And we're going to talk about why. We're going to talk about why 95% is used and some downsides of it soon. But just assume 95% confidence unless I try to always state it in the problems too. And sometimes I have you mess with it to see what can happen because you can raise the confidence. You can always raise confidence to make any difference meaningless. So Carly, we could eventually find a confidence that was so high that these two would butt up. We could. We could do that, couldn't we? We could. It would be possible, just mathematically, to keep changing that z, make it bigger and bigger and bigger until they hit each other. Then there's no difference. But again, that's bad statistics. You don't do that. It's not like I have a difference. I don't want there to be a difference. Therefore, we're gonna. It's stupid. That's messing with your sample data. You pick the confidence first. You run the study. And you see what happens. Whatever happened. My son taught me something he learned in preschool. You get what you get and don't pitch a fit. If you're trying to see a difference and you don't find one, then you go try something else. You don't tantrum. No statistical tantrums. We don't frown upon those. Now, here's the problem. Here's the problem. This is a very old study, and the reason I keep using the very old study is because I built a whole warring faction of Excel spreadsheets around it. But I don't mind using a very old study because it doesn't matter. Watch, here's why. December 2008, go ahead and read that, man boy. Sounds pretty similar to much of what you read in the papers, I would imagine. Or hear on the news. As a matter of fact, I would probably bet, if I was a betting guy, which I'm not, the previous 2 studies I showed you have way more detail than you're used to hearing or reading. They included confidence, they included a sample size, they included a sampling methodology, and they included, most importantly, a margin of error.
But they were more believable than this.
Why? Because you have those things, yes? Right!
I mean,
But Frankie, 52 is bigger than 47! Right?
Before I took this